Hi, so here's a demo of our program working. We're first running this Python file called security.py, where as the program runs, you'll see some outputs of iterations where we're trying to make a low-rank approximation of a noisy video. In each iteration, we get an L2 error, which is the reconstruction error, a threshold, which is fixed, that's an error tolerance, and an iteration number as well as a clock time. Here we see the original image, the low-rank reconstruction, and the sparse added noise. In the original image, you can see there's a lot of added noise. In the low rank reconstruction, we sort of filter out some of that noise. And in the sparse image, you see the uniform noise extracted as well as people identified in the bottom left of the frame. So now we're running the Python file play sparse, and in this file, we're just converting the CSVs, which were the matrices outputted by the singular value thresholding in the previous Python file. We're writing these CSVs to videos so that we can run Hog on them, creating sort of a CV2 equivalent of the NumPy arrays that are output from the low rank reconstruction.
So now we're quickly showing the Python file thresh.py, which sets a threshold for the sparse matrix. Essentially, we're trying to find the threshold to identify which frames actually have people in them. By doing this, we're calculating the Frobenius norm of the frame. Below the threshold means there's no people in it. Above the threshold means there are people in it. Since we're importing the output of that file into threshhog.py, we don't actually need to run it. Instead, we just run threshhog.py and import it. Here we're running Hog on the low-rank reconstruction of the original video. We're showing the Hog matches based on the green boxes. As you can see, a lot of the noise has been filtered out of the video. And it does a pretty good job of recognizing people in the frame. Then we're showing here that the number of frames above the threshold, so the number of frames we actually run Hog on is 278, and we found 198 Hog matches. We'll then compare that to running Hog on the original noisy video without any robust PCA run on it. So you can see here the frame is very noisy, and it does a little bit worse of a job of finding Hog matches in the frame. We'll output the number of matches here in a second, but it's important to note that in this video we're running it in all 300 frames, whereas previously we were only running it on the frames where the sparse matrix is above that threshold. Here we have 155 Hog matches run on all 300 frames.